What's up, automotive fan? Welcome back to the channel. If you live for the smell of gasoline and the thrill of understanding exactly what makes your car tick, you are in the right place. We have a ton of deep dive automotive tech content coming your way every single week, from engine mechanics to complex electronics. So, if you want to level up your gearhead knowledge, hit that subscribe button right now and join the crew. Today, we are going behind the check engine light. We are doing a technical deep dive into the secret language of cars, the UDS protocol. By the end of this video, you will understand how technicians talk to a car's brain to fix complex issues. Stay tuned, and at the end, let me know in the comments what technical topic you want to see me tear down next. Now, what does UDS protocol stand for? It stands for Unified Diagnostic Services. It is governed by the ISO 14229 standard and acts as the universal language for vehicle communication. Why is it used? To understand why we need it, let's look at a quick story. Now, imagine you're driving a car and suddenly your check engine light flashes on. You know something is wrong, but the car is speaking a language you don't understand. This is where UDS comes in, acting as the translator that allows a tool to talk to the engine's ECU. The technician plugs in a diagnostic tool which communicates directly with the vehicle's electronic brain, which is the ECU. Now, the ECU responds through the UDS protocol, providing critical sensor data and live fault codes. In our story, the ECU identifies a misfire on cylinder 1, reporting the code P0301. Once fixed, we use UDS service 0x14 to clear diagnostic information and turn off that warning light. And this is how the story ends. So, thanks to UDS, what started as a scary dashboard light turned into a precise professional repair. So, where is it used? UDS is used throughout the industry for communication between diagnostic tools and the electronic control unit. Now, let's get technical. How does the ECU know what we want? We use SIDs or service identifiers. This is a 1 byte code at the start of every message that defines the operation. Please check out this list of heavy hitters you need to know. 0x10, which represents diagnostic session control, which is the wake up call. 0x11, it stands for ECU reset. Now, the main are 0x22 and 0x2e, which is used for reading and writing data. I want you all to note them down so that it will be helpful when we go ahead. 0x27, which is security access because you can't just walk into an ECU without an unlock. 0x34 or 36 for the serious stuff, which is ECU reprogramming. Now, let's get into data identifiers. If the SID tells the ECU what to do, the DID, which is the data identifier, tells it which specific piece of data we want. These are usually 2 bytes or more. So, for example, F190, the vehicle identification number, F1987, the ECU serial number, 0100, it stands for the engine speed. So, quick question for the comments. Why do you think manufacturers keep the ECU serial number logged behind a DID? Tell me your theories below. Moving on, this is the anatomy of a UDS message. Request, which consists of SID plus subfunction plus DID plus data. Here remember that the subfunction is optional. The positive response, the ECU says got it, by adding 0x40 to the SID. Negative response, the ECU says no way using a NRC, which is a negative response code. Now, let's dive deep into decoding the diagnostic trouble codes. So, when you see a code like P0123, it's not random gibberish. The first character is the system, P is powertrain, B is body, C is chassis, and U is network. The second digit, 0, is a standard code, 1 is manufacturer specific. The last three, these give you the specific fault detail. Technically, we use service 019 to read these. If we send 1902, the ECU might respond with 5902 followed by the fault code. Now, guys, you might have to observe there is a plus 40 difference in between 19 and 59. We will look into it. Why is there this difference later in the slides? So, here is your answer. It is positive response that the ECU gives to the diagnostic tool. Now, whenever we also have a conversation in between two people, you give some responses, isn't it? This is how the ECU also give responses. There will be two types of responses. One is positive response, which is shown by plus 40, and one is negative response. We will go to the negative responses in the later slides. So this is one example where the diagnostic tool gives to the ECU 10 and 03 and the ECU responds with 5003. So the difference in between 10 and 50, which is plus 40, in a way the ECU is giving a positive response. Next, we will move on to the negative response. Now the negative response, how do you think so it is identified? It is identified by 7F. Here you can see 1003 is given by the diagnostic tool to the ECU and ECU responds with the negative response, which is indicated by 7F. Moving on, the negative response codes. Here you can see some of them, some of the negative response codes, where 0x31, which stands for the request out of range. If in case the requested DID or the memory address is not supported by the ECU, then there is 0x33, which is security access denied. ECU requires the security unlock before operation. 0x22, when the conditions are not correct. Suppose there is a condition of engine should be on, and if it is not met, then 0x22 can be thrown. And 0x13, which is incorrect message length or format. If in case there are some missing bytes or the length is wrong, then this NRC will be thrown. These are some examples of the negative response code. You can just pause if you want to go through all of them. Let's look at a live request. To read a vehicle identification number from the ECU, the ECU responds with 62F190 plus the hexa data for your VIN. You can go through the breakdown if you want to. Here is another example where the diagnostic tool requests a DID that is not supported to the ECU and the ECU responds with a negative response. So as we have seen earlier, 31, which stands for request out of range, and 7F is the negative response indicator. Moving on, this is another example. You can just go through it. Now, you might also know that the ECU is a very important part of a car. And do you think so that the manufacturer will keep it open for anyone to manipulate the data inside it or to read and write any data inside it? No, right? Now, what happens behind it is actually that the ECU gives you a random hex seed and your tool calculates a key using a secret algorithm and sends it back. If it matches, the ECU is unlocked. And that, my friends, is how the pros diagnose the high tech vehicles of today. UDS is deep, but once you master the SIDs and DIDs, you own the machine. Did this help you understand your car's brain a little bit better? If so, smash that like button. Don't forget to subscribe for more deep dive technical breakdowns. Thank you so much.